Next, I'm going to introduce myself. So my name is Chi. I came from LinkedIn. And this paper is about personalizing the linking feed. Actually, it's a teamwork from a big LinkedIn relevance team, including other authors like the Deepak and Bee-Chung, and so on. So linking feed, basically, if you log into the LinkedIn, you can the first thing you're going to see is the LinkedIn homepage, which is the linking feed. So LinkedIn itself is a professional network, and in this linking feed, you can see all the update activities from your friend and from the group you followed or from the company you followed. So basically, the heterogeneous update. We have more than 40 types of different kind of the update activities, like the share articles, or someone else liked activity, or your friend connect to another friend, something like that. So how to give user a good user experience in the linking feed actually is a very challenging problem because of this is a very large scale data, because we have more than 300 million linking members, and also that we need to provide a fresh feed, and we also need to consider the diversity, and we also need to consider user fatigue, the fatigue. So, and of course, the focus of this paper actually is about personalization. We want to give a user the personalized experience, right? So, for overview of the personalization, actually we do the personalization and the ranking based on the CTR, based on the click through rate. For example, let's say that we want to maximize the number of the clicks per page view, and since it's per page view, which should be the user specific, because different people have different page view, and we can have different methodologies to predict CTR. For example, let's say that we can have no personalization at all, and we simply rank all the feed by time, and we can also simply rank the feed by the global popularity of the updates. Of course, we can also do the user context specific affinities. So I'm going to cover 3 of them one by one in the next slides. For the no personalization, you can see we can do the time order. The time order, of course, is very fresh, but unfortunately, may not be relevant. And we can also rank the feed by the social popularity. For example, let's say you can see here the right up corner figure. Actually, if we rank the feed by the number of likes the activity has received so far. So you can see as the number of likes increase, the CTR actually increase in the beginning, but after a short while, actually the CTR actually dropped dramatically. So that's interesting, I know. It looks confusing. Okay, and also we can consider ranking by the update type. We have more than 40 update types, and the different type have different global popularity. If we rank by let's say the update type popularity, then actually we favor certain type other than the rest. So this, of course, actually have a huge bias on the feed. So this go to our idea actually is that we want to do the personalization to enhanced user experience. So, which means the given activity we want to compute. In this work, we want to compute 2 kinds of the affinity score, actually which is user context specific affinity score. The first one, because if you go to LinkedIn feed, right, for each activity, actually, we actually can describe the activity with 3 elements. The first one is the actor. The second one is the verb, and the third one is the object. So, and for actor, we have actor type, and for verb, we have verb type like comment, share. And for object, we also have object type like article, like the course, video, slides, and so on. So, and all the actor type, verb type, and the object type, they consist of the activity type. So, the user actually may have the personal preference on the activity types. For example, let's say if you see the left figure, you can see the we randomly sample 500 users in the random bucket data, and you can see and each node actually is one user. You can see this is the number of clicks for each user on different types. You can see for some user actually the activity type 1 a lot, but click activity type 2 a little. So that actually indicates we can split the user into two groups, and one user actually prefer one type and another user prefer another type. For the privacy, actually, I didn't mention the actual type name, but I can roughly tell you the one type actually is more content-driven, and another type actually is more social-driven. So this actually makes sense because of some users come to LinkedIn to try to make friends or grow the social network, but some other members may come to LinkedIn to digest content and read articles. So the left one actually indicates us actually we can consider the viewer type affinity, and the left one is the viewer actor affinity. Actor can be your friend, can be the company, those content generators in your feed. So if we look at the two features, one is the click and another one is impression, which means how many times you clicked on the same actor and in the past, and how many times you saw the same actor in the past. So you can see if you click one person a lot in the past, then actually the click probability is getting higher and higher. And for impression, it's a bit complicated. In the desktop, actually, if you saw the person a lot of times, the click rate actually will drop. But in mobile, actually, slightly different. So you can see that actually all these features tell us actually the past interactions between you and the actor also can choose the future CTR. So which means we can use this signal to model the viewer-actor affinity. So this is the two kinds of the affinity we used for the LinkedIn personalization. So I'm going to introduce them actually one by one in the following. So for the viewer-active type affinity model, so the idea is to compute a score of IK, which is the likelihood of score of the viewer I clicks on the activity type K, right? So that's the likelihood score. Of course, for the large sample size, you can just simply use the CTR to model this score, which is the number of clicks between the viewer and the type, divided by the number of impressions between the viewer and the type. If the value is larger, then I like the type more. But unfortunately, actually, in most of the cases, the data is sparse. We don't have enough data to model the viewer and type, all the pairs of the viewer and type. So one model we used is the gamma Poisson model. The idea actually is on the left side, we use a set of the code stuff features or baseline features to compute the likelihood between the viewer and the type. And then we try to learn adjust factor, which is correction factor between the view and the type, which is GIK, which is we call the correction factor to adjust the likelihood. So if we assume the click follow a Poisson distribution with the parameter which is expected click, right? So you can see and then we also assume the correction factor follow a gamma distribution with the mean equal to 1 and the scale equal to gamma. So the reason we choose Poisson gamma actually because they are conjugated prior of each other, so we can easily do the inference later. And after many mathematical formulas, actually we can see basically the correction factor actually is the observed click divided by the expected click with some smoothing factor. So this actually is the correction factor. So this model actually is it's very nice. Actually, it's a good balance between the cold start feature and the warm start feature. So we can use the cold start feature to build the prime model to compute the F part, and then use the interactions between the viewer and the type to compute the correction factor, right? So then, if for the pair of the viewer type, for those large samples, right, the warm start part may play an important role, but for the, let's say, the viewer type, the pairs with don't have enough data, and we can still use the cold start features to compute the likelihood. So that's the viewer active type affinity model. And for the viewer actor affinity model, we use a different way to model it maybe for the scalability reason. So let's say that we have a viewer I, actor J, activity type K, and activity T. So we just simply assume the clique itself is a follow-up Bernoulli distribution, and we can use a linear model to model the correlation, right? So because of this linear model, so we can split the linear model into 3 parts. So the first part actually is only include the features between the viewer and actor. And the second part actually is include the features between the viewer, actor, and the type. And the third part actually are the other features, which is irrelevant to the actor, right? So by this linearity, actually, we can split the feature space into 3 parts, and then we can simply treat the partial score as the affinity score. For example, let's say not all the viewer actor exist have features for some type, but we do have the features actually between the viewer and actor. So that's why actually if the Sijk exists, then we can have this nice viewer actor active type 3-tuple affinity. So which means the likelihood of this viewer clicks on the actor for this type in this context. If we don't have the Xijk features, then we downgrade to the viewer actor affinity, which is because we always have the features between the viewer and actor. So you can see we have warm star. Again, we have warm star feature and cold star features. For between the viewer and actor, we always have cold star features. So Xij always exists. But we only use the warm star like interaction features for Xij and Xijk. To give you some examples, actually, what's the warm star and the cold star features. So the warm star feature can be the number of past interactions, like click, share, like, comment between the viewer and actor, or between the viewer actor in this type. And we can also decompose the interaction features into multiple time windows. Because of if I click you a lot recently, probably I like you more comparing to if I click you a lot a long time ago. So which means we also decompose the interaction features into multiple time windows. Again, this is some figure we just showed before. And for cold start features, basically we have the interactive features between the viewer and actor based on their profiles. For example, let's say the education, job, location, and skill. The idea is probably 2 persons, they are in the same with same skill or in the similar education level, they like to click each other. So that's the assumption. So, but we let the machine to learn. We don't actually. So, because of the profile features space is huge, so that's why actually we do the top-end profile feature selection. We simply do some offline analysis and pick the top 1,000 to 2,000, something like that, and to see the CTR lift. And finally, we fixed n equal to 2,000. And for social network features, you can see we can use number of common friends or use the number of connections clicked on the same actor in the past as the features. And this bottom figure actually tell us actually for different update types, right? As the number of connections connected or acted on the same actor increase, also the CTR also increase, which makes sense. If you go to LinkedIn feed, if you saw a lot of your colleague or your friend like the same article, you probably also want to like it or click it. So, okay. So after prepare those features, and we actually joined the Chen, the click prediction model based on the ADMM, which is a distributed logistic regression, right? The basic idea is we split data into multiple pieces, and we train a logistic regression for each piece, and then do some merge based on some algorithms. This actually, you can see the details from the RT work. And okay, and finally, we actually deployed the affinities online. So the left side actually is our online deployment workflow, and the right side is some offline workflows. So you can see the after we receive a URL request, and we get top-end activity candidates, and then we access the database to get the features, and retrieve the models from database. We also retrieve the affinity score from the Watermo, which is open source software by LinkedIn, which has a key value store. So, and then linearly combine them together as a final score. We do have some offline jobs to update the affinity score in Watermo store within the key value store. We do the daily update because we compared with the hourly update and 2-day update. We found actually the hourly update, the lift of the additional benefit of hourly update is not too much. So that's why we choose the daily update. And this actually tells us the affinity score we computed every day is very large, right? It's at billion level, tens of billion level. And to reduce the score, we also constrain actually between the viewer and actor. We only retrieve top 10,000. Okay, here we do some A/B tests on desktop and mobile. You can see the because of time constraint, actually, I just simply quickly go through this result. So the basic idea, you can see the without comparing to the baseline no affinity, the type affinity actually can improve the result a lot. And then we gradually enhance the baseline by adding the type affinity to the baseline, and then compare with the new actor affinity, and then compare with the new view actor active type affinity. So that's the mobile A/B test. Okay, to summarize the talk, actually, you can see the personalization of final granularity actually achieve higher CTR because of the view actor type affinity is better than view actor affinity and better than view type affinity. And also when we design the production product, this actually is in LinkedIn product already for around 1 or 2 years. So the scalability and the data sparsity actually are two major concerns when we design the models. Some future work actually including we can do the activity-dependent personalization. For example, let's say we can compute the affinity between the viewer and the content topic of the activity. And we can also do the personalization at the viewer ID level. We can train the model for each user. Okay, so that's conclude my talk. Thank you very much. Any questions? Okay, Chris.
Thank you. Very nice talk. Slide number 5 was fascinating. If you want to bring the plot.
Which one?
Number 5. Slide number 5. Yes, this one. There seem to be spikes at 5 and 10, right? The click activity of type 1, there seem to be a lot of 5 and 10. Is that due to blogs?
That's a very good point, actually. In this corner, which is confusing corner, with those users actually like both. For the clarity, actually, we removed this point.
But there are spikes at 5?
Yes.
Spike at 10?
Spike 5 and 10. Yeah. And your concern is the...
Too many people with 5 clicks of activity 1 and 10 clicks of activity 1.
Okay.
Due to spam, this is why so many 5s?
It's not spam. I think this is data problem, actually, because, yeah. Yes. Any other questions?
Do you have a rank list of the most popular activity feed on? I know it must be different from the only for China's math puzzle. I usually saw that. So any other most popular feed?
Most popular activities types, right? So I didn't label the popularity of the activity types because of this here, right? Actually, the different activity type have different popularities. And which one is the most popular one? Actually, I didn't label them because it's quite confidential. So we removed the labels from the paper. Yeah, but I can roughly tell you actually the connection update very popular, which means your friend connect to another people. And also the share article is also very popular. Yes. Any other questions? Okay, if no, actually I think we can finish this session, and thank you very much, people. And now you can enjoy the lunch.